Well, I will briefly do a quick introduction here, try to be brief. Good morning, good afternoon. I'm Susanna Brady. I'm Senior Vice President of Sales and Marketing for Cobalt Digital. I am also the RIST Forum Chairwoman. I just want to say briefly that this isn't your standard webinar. This group of participants, I should say, a lot of these guys are part of the core team of the RIST activity group. And we discussed a couple months ago, what can we do? How can we do this differently? And we had the idea to do a live hands-on session with really access to a remote lab environment where you could see and watch live several different things. So we're going to simulate a real network conditions here, jitter, latency, packet drops. We're going to compare how RIST and SRT really react in real time. We're going to be able to access multiviewer and receiver.
Turn on my camera so you can.
I'm sorry. And we're going to be using, monitoring tools from all the leading partners that are going to be participating here. So whether you are testing transport protocols or exploring real-world reliability, this is really your chance to go beyond theory and get into the infrastructure, to the real deal here. So I'm going to briefly first introduce our panelists. As I like to call this our dream team. This is the RIST dream team. It's really the guys who work day in and day out on the technical recommendations, all the protocols, people who make it all happen, and hundreds of years of experience here. So first, Dr. Cyril Naroya. Dr. Cyril Naroya is the Chief Technical Officer for Cobalt Digital, and he's also the RIST Forum President. Mr. Jack Douglas is the VP of Marketing and Business Development at Packet Storm, and he's also the Video Services Forum, the birthplace for the RIST Forum, and he's the VSF Treasurer. Dr. Sergio Amirata is the Chief Scientist and Founder for SIP Radios, and he's also one of the RIST Forum Directors. Mr. Adi Rosenberg is the CEO and founder of Alpha Links, and he's also a RIST Forum Director. Manjinder Sandhu has contributed many, many times. Thank you for having you again, Manjinder. He is the product specialist of Evertz. And we have also here on the session, although he's not an official panelist, but he always has lots to add, Rick Ackermans. He's the Director of RF and Transmission Engineering at CBS, and he's also the RIST Activity Group Chairman within the VSF group. So RIST, as you know, just if any of you haven't joined us before, we're all about a combination of interoperability and innovation. It's been developed jointly by this group of experts using a standards-based approach. RIST provides an open, interoperable, and very technically robust solution for low latency live video over unmanaged networks. So with RIST, interoperability is always achieved through clear specifications, while all the vendors are able to remain free to innovate, within their own implementations. And this is what you're going to see here today: flawless, contribution of many vendors, just in the RIST environment. So a little bit on the RIST AG. RIST AG is the technical side of the RIST group. It's AG is for activity group. So this was created within the Video Services Forum in 2017 in response really to industry requirements for such a protocol. The group has developed 3 main technical recommendations for the base protocol and 6 additional TRs, for all ancillary functions. All the specifications can be freely downloaded from the Video Services website, so feel free. And also there's a free open source implementation that's available. It's called the LibRIST that was started by Sergio, and it's really, really useful. We wanted to bring us up a special slide here today just because we have some very latest breaking news with Trump's big, beautiful bill Now there's a provision in the bill for mandating that the FCC auction half of the remaining C-band spectrum. And basically, the satellite C-band in the US is going away. There was an auction a few years ago. It was very profitable. So now they're saying they're going to do it away soon. They're going to do it again. So satellite feeds will really move to hybrid or terrestrial. And this is a really good timing for us to talk about this because the RIST AG has just finished the work on a new TR, and it's for the satellite hybrid operation. And so that's where transmission is via satellite and KU band and packet recoveries over the internet. So this is a really good opportunity for RIST because the KU band offers very poor resilience to rain fade, and RIST could be a great solution for many applications in this environment. So don't know if I should talk. I'm not talking about the big, beautiful bill.
Yeah, Suzanne.
I'm not going to go there, but I'm going to say that it's exciting for the RIST activity group to see many opportunities here to save to help you get away with this big change out there.
Yeah, Suzanne, can I make one minor? So what's in the legislation is half the spectrum is being taken away. Okay,
half of the remaining.
It's a must. The other, the FCC has the authority to take the other half away. Mm-hmm. We'll see what happens, but half of it is going away, and it is mandated that it go away.
Mm-hmm. Yeah, so we're watching closely. Obviously, the technology is here, available for use, and stay tuned, for what's going to happen next. Quick agenda here, so we get onto the action here. There's going to be a test environment description that Sergio is going to explain what's going on today. And then he's going to give a quick introduction on SIP radios, packet storm. We'll make an introduction, how the network simulator is working. We're going to do a quick introduction on everts and how everts is contributing today. The same with Cobalt and all the links. And then we're going to run a test section at the end. And please feel free to contribute, participate, ask questions, and live or on the chat box, and we'll be checking.
They bring that out.
So go ahead. Sergio, I think you will be next.
All right. So we're ready? Okay, I'm going to share my screen now. Hold on. This one. Okay, can you see my screen?
Yes. Yeah.
Yes.
All right, perfect. All right, so well, thank you for joining the hands-on with RIST, the live online workshop. My name is Sergio Amarada. I'm the chief scientist and founder of SIP Radios, and I'm also a director of the RIST Forum. Let's start with an overview of what we are showing today. Okay. Hold on, I skipped one. Sorry about that. There. Okay. So in this workshop, we will be demonstrating real-time streaming from several points in the US and Canada to our data center here in Florida. Our data center meaning SIP Radio's data center. We're going to go through two independent connections, or ISPs. In this case, it's a little bit of a simulation of an ISP, but it's still two independent connections with public IPs independent of each other. And we're going to have both RIST and SRT streams coming in through one or both of them. We will have the opportunity to manipulate network parameters in real time and affect any of those connections coming in. So who's involved, specifically on setting up the workshop, doing the hard work? These are the companies and individuals that actively participated in setting up this workshop. Thank you, for making this happen and for the time that was put into this. So let's jump into the network diagram that explains the infrastructure that is hosted here at SIP Radios. And as you can see, on the bottom diagram, on the bottom side, it all starts with in the box in the upper right hand side that says AT&T. That's basically our internet providers. We have fiber enterprise fiber coming in. We have hosted services, so our fiber is not your typical business fiber. It's a true enterprise data center fiber with the ability for us to broadcast our own IP addresses. We have our own ISP license, Cypredius does. So we own blocks of IP addresses, and we've set up 2 Class Cs of public IPs that have BGP bound to the AT&T provider. And that's why you see the master router there. It comes into our master router, and then we split it into 2 separate Class C public IPs to simulate 2 independent connections. In a real world scenario, this could be a fiber coming from AT&T and another one coming from Cogent or from other provider, being routed as 2 independent connections to a data center. In this case, we're doing through a single link. We see the Alba Links network monitoring tool is right there on that junction, getting a copy of all the traffic. And Adi will explain what his tool does and the metrics that it will be able to give us. So once the data goes into our infrastructure through the master router, it gets split into the 2 public IPs that are going to be exposed. And then it goes through the packet storm network emulator through 2 independent paths. Here it's labeled net emulator A and net emulator B. So you can think of this as now, not only do we have 2 ISPs being simulated in this infrastructure, but now we can control the network parameters of those connections, meaning impairments. Let's add more packet loss, let's add more latency, let's add network jitter. We can control a ton of things to pretend that our internet connection is the one having the problem, which in this case it doesn't, because our fiber is pretty strong, but it could be on the other side. This allows us to manipulate those parameters in real time, and it's part of the things we'll be doing in this workshop. Then, if you follow the lines on the left-hand side, they go down into our Cypredius Media Gateway, and that is basically our RIST and SRT receiver. It's the endpoints is the receiver end of several RIST streams and several SRT streams. Some of them are coming from Cobalt, there's one from Evertz, and there's 2 coming from Cypredius from another data center that we also have. So this media gateway receives the RIST, takes out the data inside, which happens to be MPEG-TS, and pushes it as UDP into what we call our multicast switch. So that's the backend fabric where we hold all our streams. They're all shared there so that they can be picked up by different devices that are going to manipulate them and make them easier for us to display to you, right? So now we're down to the multicast switch. And the multicast switch then, on the right-hand side, we have what we call the map multiviewers. I'll talk about that product a little bit later, but what it does, it picks up multiple of those streams, and it builds a server-side mosaic or multi-view of those streams for you to be able to look at several of them in real time. So we have 2 of those. And then we have the media server, also the Cypredius media server, that is capable of grabbing that same multicast UDP data streams that are on a multicast switch and convert it into a WebRTC playback. The WebRTC playback, and we'll demonstrate shortly, is a way for you to also monitor not only the individual streams, but the multi-viewers we have created through an easy-to-use web interface that will give you real-time access to all of this. And then the media server, again, goes back to the master router, and that's how you're going to be accessing some of the streams. So I'm going to pause here for a second and see if anybody has some questions or doubts about this diagram so that we can cover them now before we dig into some of these exercises. All right. Anybody monitoring the chat? No questions? Okay.
I see a hand raised. There's a hand raised, Patrick.
Okay, somebody wants to...
Go ahead, Patrick. You're muted.
Okay, I'm unmuted now. Thank you.
Thank you for going over that, Sergio. My name's Patrick Madigan. I worked at quite a few of the broadcasters and streaming companies, so very excited to hear about this and get dig in with you folks. My question is, I read in here, who are the senders and who are the encoders being used on these? Because that's also an important factor in doing end-to-end distribution, whether it be distribution or contribution.
Correct.
The other question I have, is there any QoE devices to do in measurement the quality of experience of the audio and video itself, being a golden eye myself and looking at quality of the video and audio? So I don't know if any of those tools are available, because that's also an important element in my career, making sure we're putting out good quality content.
Let me take some of those questions.
Okay.
For the encoders, Cobalt, Evertz, and SIP radios are providing the encoders. They are coming. Cobalt's coming from Champaign, Illinois. SIP radios is coming from Florida itself, but a different location. And Evertz is coming from Canada. In terms of actual video quality of experience, we don't have a measurement, but you're going to be able to just see them. You have access to the streams. Now, those are 1080p, sorry, 720p streams at about 5 megabits per second. So compression is good, but not maybe the best. But the point here is delivering all the bits. So what we are looking for is network impairments, and for that we have tools looking at that. What's happening to the in the network?
Right. And you're using AVC or HAVC?
We're using AVC. Those are 720p AVC streams for simplicity. Okay, and Sergio is going to share links for you guys to pull the multiviewer directly into your machines.
Yeah,
Gotcha.
we do have SIP Radio has a tool for measuring the quality of the video itself. It's not showcased here, but we do real-time measurement of the quality of the video. But that wasn't the point of this. We're going to show tools that measure the quality of the transmission. You know, are the bytes getting there? What is the bit rate? That type of thing. The video itself in this particular workshop is kind of irrelevant, so it's not going to be the best quality ever. It's just something that is good enough to show and good enough for you to view as well through a web browser, which is part of this, the whole purpose of this demonstration, have given the participants the ability to monitor in real time. All right, if there are no more questions, I'll go to the next slide. So now that we understand what we are testing, let's explain how we are going to monitor this in real time, not only by us here, the ones that plan this, but by everybody else that is participating in this workshop. So the key to this is now I'm going to talk about the products that were involved in this monitor, is our SIP Radio SIP TV system. You can think of it as a broadcast toolkit for monitoring of streams from anywhere. It provides a map to your streams. As a matter of fact, we commonly call it the Media Access Platform, or MAP for short. This is a little bit of a diagram of what that product can do. You can have production facilities everywhere, A, B, C. You can have people everywhere as well. And this system will allow you to have the stream geographically distributed in many locations of viewers, also geographically distributed in any location, just like we are here. It allows you to monitor them from a centralized location. We also provide RIST-based set-top boxes for viewing, but the one we're going to demonstrate here is going to be the web-based WebRTC playback. And this is all available with a full end-to-end DRM and authentication model as well. Okay, next slide. A key feature of what we're going to be showcasing today for this monitor is the ability for this multiviewer, or for this map SIP TV system, to display multi-views of the stream. You can create client-side multi-viewers, or we can also create server-side. In this case, we're going to be showcasing server-side. We'll be giving you access to this tool for the workshop, and we're going to walk you through the different channels that we have defined on it. so that you can follow us during the presentation. So lastly, I would like to talk a little bit about the infrastructure that we have in place in our data center. Everything is coming to the SIP Radius data center and is being routed and hosted by SIP Radius hardware and software almost in its entirety, except for the packet network emulator by Packet Storms and the Alpha Links network monitor, which are there as an independent and impartial validator of the streams and network flows. So, and when I say everything is going through SIP Radius hardware and software infrastructure, I truly mean everything, including the edge router. This is a device that is part of our product line, and it includes everything an enterprise router should have. You know, everything a Cisco Juniper router has, we have it as well. But we do something different. You know, we also have BGP, of course, for the IP address routing. We over-engineer these routers with a gigantic amount of CPU and RAM to make it adequate and optimal for broadcast transmissions. In broadcast transmission, network jitter and spikes in bitrate are common and are often overlooked by normal routers and switches. So we created a series of products that are optimized for that type of network flows. And that's part of what we see here in this infrastructure. So now let me give you a short tutorial of the tools we will be using. Now that we've seen the products that are involved, let's give you guys access to the tool. I'm going to put this in the network chat. I can find it now. It's here. Okay. And I'm going to wait for people to open it up. Let me log out so that it will be the same as you. Okay. Okay. Can everybody see my screen now?
Yes.
Yes.
So when you come in, you're going to see this, right? We've set up the guest access, so just click on login as guest. Okay, so you should be in the same screen. You select the location, hands-on with RIST. We have two categories, map 1 videos and map 2 RIST stats. Each of the categories has a series of video. The first one has 10 videos or 10 channels, we call them. The first one, if you click on it, you'll see this show up in your own screen. Put it aside, put it in your second monitor. You'll be using this tool quite a bit during this demo. So here we see on channel 1 shows our server-side multiview that has information about the streams. There's a total of 6 streams coming in from remote locations. The upper left-hand side, SIP Radius, RIST coming in with 2 peers, meaning we're sending through both connections at the same time or ISPs at the same time for a full 2022-7 experience. The middle one on the top, it's coming from Evertz in Canada. It's only one connection and it's RIST. And then the last number is the buffer size that we put on that. We put different buffer sizes just to demonstrate what happens. The third one on the top is Cobalt, RIST with also 2 peers and a 3-second buffer. The one in the middle is coming from another data center here in Florida, SIP Radius, and that's a 1-peer stream, and that's just our promotional video going on there. On the bottom left side, we have a SIP Radius SRT, 1-peer, coming from another Florida location. And the one on the bottom right is a Cobalt stream coming from the same location as the first Cobalt, but this time is an SRT stream with 1 peer and 1-second buffer. So that explains the 5 video tiles. Now there's another 3 tiles in here. Let me explain those. The bottom tile in the middle, we call it tile number 8, sequentially numbering them. That's the Packet Storm network emulator, and it has a label there. It's showing 2 graphs that are going to be part of what we're going to script it as a demonstration before we go into interactive mode. But behind those 2, you will see that there's some network controls, and those network controls and buttons have been predefined to match each one of these videos on both directions, data coming into the data center and coming out of the data center. We're going to be able to change the parameters for them independently. That's the bottom middle tile. Then the tiles on the middle left and middle right are statistical tiles. They're virtual machines running on our map. Our map is also a virtualizer, so you can host virtual machines. And we have web browsers, a small VM running a web browser, pointing to a statistical graphs. The one on the left is Alvalink's network monitor, and Adi will explain that when he does his presentation. And the one on the right is standard tools coming from our router. In this case, we're showing the network bandwidth of red and blue networks, using the standard nomenclature where you have path A and path B with redundancy, right? In this case, we call it the red and blue network on the diagram, and that's what you see there. On the multi-view now, you see that there's, besides the multi-view in the map 1 videos category, I clicked on the first one, but if you see there's T1 to T9, which is basically a pointer to play the videos independently on a higher resolution, because sometimes this is too small, but not sometimes, it is too small. Even though this is a 4K surface, what you're seeing right now with 7 megabit, is still not big enough at times where you need to zoom into one of the videos. So if you click on any one of these, T1 or T2, you'll be able to get a direct playback to that video with a full high res, with a full HD playback on your machine. That is particularly helpful. Let's say if you want to, Ari's talking about his graphs and you want to see it in full screen, that's what I'm doing now. Or if I want to see and have another third monitor, open up, monitoring what's happening to the network bandwidth on red and blue networks while we're running these tests. And you can put this one there. The point is, this tool allows you to not only view everything at once with the multi-view as a 4K surface that is being streamed to you, but also each of the individual tiles. Anybody have any questions about the multi-view, the primary one? Can everybody open it, see it, play it?
Yes, Sergio, we need to kind of pick up the pace.
All right, let me go fast. The second one, the map 2, shows statistical graphs provided by our RIST receivers, and we have 4 RIST streams, and that's what you see here. The 4 the statistical graphs, I'm going to dig into one of them just to explain the different tiles. This is the bandwidth on the top left. The middle one on the top, lost packets. And the middle on the top right is unrecovered packets, where you see a big blank nothing, which is great. It means we have been able to recover every single packet going through. And you may ask, why are there so many lost packets? Because we defaulted to 10% packet loss at the beginning of this demo. Then the other graphs here are the measured RTT in real time, the link quality as a calculated measure. And the lower left-hand side, we have the reorder and recovered packets. The middle bottom with the number 2 shows how many connections we have coming into this RIST endpoint. If you see the 2, it means somebody's sending through 2 different ISPs. If you see 1, it's only 1 connection. And lastly, on the bottom right-hand side is a real-time measurement of the network jitter of the packets coming in. We call it inter-packet spacing, and you see the scale is milliseconds. And again, you have the 4 tiles, and you have the multi-view if you want to keep an eye on what's happening in real time while we run tests, while we increase or decrease the packet loss on this. You'll see in real time what's happening here. This is show a rolling 5-minute history of what we're going to be what we're going to be doing.
Okay.
That's
Thank
it.
you. Thank you, Sergio. We will now go on to Jack he's going to talk about the packet storm network emulator that's being used in the test. Go ahead, Jack.
Yes. Why all these pictures came up at the bottom here, but hopefully this will go away when I move this out of the way. Okay. So I'm going to talk about the Hurricane Network Emulator from Packet Storm. This is what the box looks like. We are able to do impairments of all different types here. Delay, jitter, drop, reordering, throttling, jitter, bursting packets, and so on. And you're going to see impairments that look like this. And we're also going to have plots that we can click on here and show a plot. These plots will be shown live during this demonstration. We have two models of this. We have a Hurricane 6, which is the one that's being used here, which has 10, 100, 1000 ports. It is also 2, 4, 8 ports, and there can be 32 different filters. Each one of these is a filter that you can see here per port. There's also a Hurricane 7, which has 10 gig ports, 1, 10, 25, and 100 gig ports. And there can be 2, 4, 8 ports there, and up to 64 different filters. So there are really two parts in this demonstration. We have some links that have two paths. So you can see here, this is a red network and a blue network. So this is 2022-7 with RIST, and this is the return path. So this is the primary path and the return path. And again, the primary and return path for the blue network. There are also some SRT flows that are here in this. And you can see that the forward path and the return path, and the forward path and return path, but these do not have redundant. They're not 2022-7. So with the SRT, you can only have one path, which is an important thing to understand, because if you do have problems with one path or losses, the 2022-7 can correct for that. And that's all that I have there, and I will stop sharing.
Thank you, Jack. We'll have Manjinder from Evertz talk about the Evertz products, what he's using here for the demo.
Hello, everyone. My name is Manjinder Sandhu, a product specialist at Evertz. I just want to use this opportunity to talk briefly about our Mio XPS platform that's being used in our demo today to send streams from Evertz headquarters located near Toronto, Canada. So Mio XPS is our Evertz, it's a new gen video encoder decoder. It's a dual slot Mio module that's part of Scorpion Media Edge platform. It supports HEVC, H.264, 10-bit, 422 video encoder. Supports both RIST and SRT protocols with full encryption, provides ultra low latency. It offers centralized management via VistaLink, Magnum View, or WebGUI. So here's some of the Evertz Scorpion enclosures that this Mio XPS can be housed in based on your density and application requirements. Scorpion 2, it's a mini Scorpion frame that can take two single slot Mio modules. And then Scorpion 6, it can house up to 6 single slot Mio modules, and Scorpion S18, X18, high density can house up to 18 Mio modules. And the biggest frame Scorpion offers is Scorpion 2. I use the latest one with the upgraded features and designed for high density applications. It's a Scorpion 2 RU. I want to mention that we Evertz have a whole ecosystem of hardware and software products and solutions that support internet and cloud, video and audio distribution via using RIST, SRT, and other streaming media formats. Talking about some of the applications here, starting off with remote production. So in remote production, you can have a Scorpion rack with Mio XPS encoders, streaming HD or 3G video using RIST, SRT, or SRT over the internet to a studio for mixing and playout. This is common in news gathering, sports, and entertainment businesses. Second would be cloud on-ramp contribution. So video input encoded at a remote site, transmitted securely to cloud or broadcast IP infrastructure, then can be then decoded using the Mio XPS. Another one would be live event streaming. You can encode live camera feeds and transmit to a control room or a remote team. This is used in esports, interviews, and field reporting. Last but not the least, disaster recovery or backup links. So you can establish resilient encrypted media paths over public IP networks with the built-in ARQ FEC using RIST or SRT reliability. It provides an alternative to leased or fiber paths. Our IP and cloud-based streaming ecosystem offers internet-based contribution by sending secure, reliable feeds over public IP or managed, unmanaged networks using products like XPS or XG. Cloud integration, we provide native support for cloud playout and processing using platforms like Evertz.io, Mediator, Overture, and Bravo. Evertz Magnum iOS provides end-to-end orchestration to unify control and monitoring. Our products support full protocol flexibility, allowing our customers to pick and choose formats of their choice. For example, RIST versus SRT, ZXI, and many more. For more information about these products, you can go to evertz.com. Thank you. That would be all for me.
Thank you, Manjinder. I'm going to do a very quick introduction to the Cobalt stuff that is used on the demo. So I'll be quick about it, so we have time for the good stuff. That's
Can
me.
everybody see your shared screen?
And
Okay.
if there's any questions, does anyone have any questions so far? Okay.
Okay. Here's the good slide, the one that this is what's happening at Cobalt in Champaign, Illinois before it comes to the demo. I'm starting with a media player with that Carnival clip that you see going on. It's actually a 1080i signal. This is Carnival in Brazil, in Rio, from 2003, 22 years ago. Just because I can, I don't actually have to do this, but because I can, I have a Mindback Grandmaster. It's my 2110 network, so I have that already. That's giving me a black burst with VTC timecode. I'm going into Cobalt frame sync. That's adding frame syncing it to GPS as again not necessary, but adding a bouncing box and a time code burn, and the time code is actual time in the central time zone. So that's the image that it's making. That goes to a Cobalt 9992 encoder that is converting that to 720p. So it's all the same in the multiviewer. And the same encoder is sending the stream, the RIST stream, with 5 megabits per second. And I'm using one of the features of RIST. It's called no packet deletion, NPD, where you put flags for the no packets and regain that bandwidth. So it's saving a little bit of bandwidth on the way out. So it sends 2 copies of the RIST stream, and it's sending also an SRT stream. So that gives you the same system with both RIST and SRT. And that's what's going to the multiviewer at SIP radius. So one of the things you can do if you want, this is the current time in central time. So if you pull up, like, for example, the NIST time widget, you can see what the latency is from Cobalt to you. It's going to be about 10 seconds because of the decode and re-encode, but that's a real-time measurement if you want to see. We also have an Alva Links agent in our network that is doing some network management, and Ajay will talk about that. It's doing end-to-end path measurement. Cobalt's got a whole bunch of RIST-enabled stuff, encoders and decoders and a gateway. I'm not going to go into the details on that. We support simple and main profile with the DTLS encryption and authentication in some products. And you can put them on OpenGear chassis. Some of you may be familiar with OpenGear. It's a chassis, it's industry standard chassis where you can mix and match cards from different vendors. Or if you want a little box, we have that as well with the BBG 1300FR. Again, if you are interested in that stuff, you can find in the Cobalt website. I don't want to take too much time because we need to go to the demo. So last presenter will be Adi Rosenberg from Alvalinks. He's going to talk about the Alvalinks solution that's running over here. Adi, if you're talking, you're muted.
Thank you for that. Okay, I will try to be very fast. The reason why Avalinx is participating in this endeavor is to show you Avalinx capability to monitor the network. Many of you have been probably frustrated from the lack of information coming from the network or the circuit providers about what is going on the network. Usually you will have statistics, but not clear visibility of what's going on. Avalinx tries to address that. We are basically the missing piece. We are proactively testing the network. For instance, in this example, we are testing the network between the Cobalt facility in Champaign, Illinois, to SIP Radius facility in Miami. We want to take out the finger pointing, the blaming. We want to save the time, see the problems as they happen, and try to find the correlation and the quick root cause analysis, because the tools that are available today for the users are inadequate to do that. Now, talking about in-flight, we have developed, we have an SRT in-flight monitor, and for this event, we developed a RIST that is going to be integrated into the available solution that are out there in the field. And why do you need that? Basically, with in-flight probing is just having like a real-time Wireshark on the network. We can then measure RTT, jitter, packet loss, how the ARQ is performing. We test and discover the network path, the route that you are taking, and we actually validated the SRT path that we measured against what we measured from the site from Cobalt. With that information in hand, you can see what is going on. You can have better visibility, where the problems are, how you can tune your buffer, what do you need to do. All those questions suddenly fade away and you can focus on the primary job, which is content delivery. I'm not going to go into why do you need observability. I would skip that, but believe me, with 20 years experience in video over IP, you really need to understand the network, because this is your lifeline. If you don't, you will basically be chasing ghosts in the system to find out what's going on. Finally, basically where RIST and SRT come into play. In this example, we have different examples. Sport events. Some are using SRT in the US, some are using RIST. They might not even know that they're using RIST. Remote contributors using SRT RIST, station to station, coming in. Those are remote location. You may not be in control of that source. When it comes to your premises, you want to have a visibility and you want to have understanding what is going on. So that with our in-flight probe, you can have that, and we will demonstrate that during this event. If you have any questions, come back to me. Basically, what you will see is that it's like a Grafana chart. But in order to make it easier, we created like a scoring. We call it a DPS. It takes all the real-time parameters into one score, giving you a much more easier understanding for you to understand what is going on, whether you need to take note or not. And this also applies to the people operating. They not need to be skilled in SRT RIST. They just need to keep the score above 90 and everything is okay. Thank you for the time.
All right, thank you, Adi. So now there's only one screen being shared, which corresponds to the Packetstorm network emulator. We are going to take you through a couple tests, and then we'll take requests. It's not practical to let you operate the equipment, but we'll take requests. So what we have right now is 10% packet loss on all links. And Jack, can you move the plots so we can see what's going on? We'll have two plots. one of
And you want
them,
to see over here on the right?
yeah,
Or you
we
want
can
them
see.
on top?
No, that's fine. That's fine.
Okay.
One of them is the RIST, and what you should be looking is the green line. The SRT is on the left, right? What you see is on what you're looking for in the top plot is the green line, which is the total bandwidth, and you see that at 10% packet loss, SRT is taking a lot more data than RIST. Both are clean, as you can see in the multiviewer, but SRT is taking a lot more than RIST. The RIST stream here, those are the two cobalt streams. The cobalt has got an advantage because it's a -7, so it has both red and blue network. So now I'm going to ask Jack to put 100% packet loss in the red network. You will see no glitch because you still have the blue network. So
And actually, let me show this one on top then.
yeah,
There you go.
just
Yep, and I'll move this back. Yeah,
100%.
Maybe I will share also my screen so they will see the impact of that, or they can see that.
Yeah, go
on
ahead.
Let's do that in just a minute. Oh, okay.
Yeah, so that well done. That is
Okay, so I'm
configuring.
on to
So
7.
just to show you. So right now, this is the link. This is the RIST link coming from, this is outside before the emulator. So you can see here, this is the stream rate. And because it's a 70/2020-7, the amount of packet loss is barely minimum. Few packets get out, but there's no impact. That's why we can see that the RIST shows better performance. Using the same stream over RIST, you can see the same outcome. And you can see that the amount of ARQ, the SRT ARQ right now, and we said that it's 10% packet loss. You can see it's almost 1.5 megabits, which is 30% overhead. So we have 10% being lost, but 30% being sent to recover that. What that means that excessive bandwidth might cause damage to your outgoing streams. If you have multiple streams, it might damage the incoming stream to your organization. Now you might have alarms or failures on different streams, but you will go and chase those ghosts in the network because you don't understand that it's coming from a different stream that is causing the noise and harm. So this basic test, and just you can see here once again,
Okay.
the SRT falls short.
Thank you, Wajid.
Okay. And I have 100% on one leg at this point.
Yeah, so Jack put in 100% packet loss on the red network. The RIST has the blue network, so it's a single link, just like the SRT, and there was no glitch. Just to prove to you that we have two networks, temporarily put 100% loss on the blue network, number 9, 100%.
Okay, and now I'm going to add the 100% here on this link.
So that's gonna completely kill the Cobalt RIST stream. You will see since it's got a buffer, it's gonna go for a little bit, but then it's gonna freeze and go away. There will be the top stream. Now it's frozen if you're looking at the multiviewer, and then it eventually goes to black. So we killed that stream. Now bring it back. Go ahead,
and if
Jack.
you look on the packet storm, you can also see it dropped out. Okay.
Right.
And
Bring
I'll bring it back.
10% packet loss again. So we took one link and then the other, and now it's dead, but it's going to come back.
And you can see it come back.
Yeah, and you'll see the video coming back. All right, so we're back up. Ralph, right, so let's go to 20% packet loss on 9 and 15. So we're going to 20%.
It's still leaving it's still leaving one link down.
Yeah, we have handicapped the RIST to have a single link. So let's go to 20% packet loss in the RIST and SRT streams. So again, we're messing with the cobalt, the two on the right side of the multiviewer, top right and bottom right. since we have a lot of bandwidth, they will be able to keep working. But what's interesting is what it takes to make them to keep working. So is it in place? Let's see the plots,
It
Jack.
is.
Let's see the
All right,
plots.
move the plot over. So this is the RIST, and this is the SRT, and you can see that the bandwidth is significantly higher here.
Okay. Ajay, comments.
Well, we can see that the SRT is ramping from 1.5 or 1.7 to almost 3.2 megabits, which is quite high. Comparably, the RIST is on 1.3. So it's like 30, it's like the SRT showing 300%, 200% more than the comparable RIST at the same, given the same condition.
And I would also note that these are two completely independent implementations of RISC in the sending and the receiving side. It's Cobalt on the sending side, and LibRIST, the open source one, on the receive side. So both developed independently from the spec. Do you want to add anything, Sergio?
Yes, basically, you know, the key here is that if you have unlimited bandwidth, yes, you know, they both seem to work the same, but they don't really, because the overhead of recovery is a multiplicative factor of the missing data. In the case of SRT, 3 or 4 or 5 times, depending on the amount of data loss, versus almost exactly the amount needed when we use RIST. If you're missing 10%, you had 10% overhead to recover that 10%.
Okay, Jack, let's go to 30% on 9 and 15. So we're going to 30% packet loss, both on the RIST and the SRT. And we'll see what happens. One thing that, if you don't control your retransmissions, one thing that can happen is a negative feedback. Different people call it differently, but what happens is you lose packets and the retransmissions burst. And if you have limited bandwidth, that causes more packet loss, and in turn cause more retransmission, and eventually your link goes down and is unusable, and you really have to reset the system if you don't have protection against that. We're not going to see that happen here because Sergio's got a gigabit, but you'll see that it can happen when you see the bandwidth. Is it in place, Jack?
It is.
All right, what do you see, Jack?
So you see that the RIST has stayed pretty much at the same bandwidth here. And you see that the SRT is clear up to 16 megabits per second.
You can see that kind of stuff also on map 2, the multiviewer, the stats. You'll see the increased packet loss and the recovery, but that only has the RIST. Ajay, your observations, please.
Just like Jack, where the SRT is like it's completely almost completely overtaking the stream. So it's the number of RQ and the number of packet streams are the same. While on the RIST, even with some small packet loss coming from the network, we are still like 2.4, 2.5 megabits, which is far less, 50% less than the SRT, given the same conditions.
Yeah.
And more packet loss, I have to say.
Now, if I may make comment here, an important factor of this test is that we're sending the exact same bit stream. Byte by byte, the SRT and the RIST have the same video inside coming in. So we are truly comparing apples to apples as far as everything coming in and the amount of retransmissions, the amount of data being recovered, it's all identical. It's the difference is the transport. Go ahead, Cyril.
Yes, and we had to ask Jack to put the network emulator because we couldn't. The internet is actually pretty good these days, so we wouldn't be able to show anything. So that's why, and we invited both Jack and Ajay because those guys are conscious, right? They are independent observers. So Jack, can you bring the system back to 10%?
I can.
I think there is a request to do 50% from the audience.
I can.
Yeah,
You wanna do that?
go do 50. Yeah, what we're going to do next is open for a few requests and see what happens.
Yeah, the first one is 50% on both links, meaning 7 and 9 and 15, Jack. You're gonna have to put 50%
Okay,
on all three.
Leave 7 at 100%. Oh,
okay,
yeah, leave 7 at 100% for now. Just do
okay.
9 and
Yeah, I
15.
can change it in a minute here. And so 15, I'm going to go to 50%.
Although, you know what the protocol is when you have 50% packet loss? The protocol is you pick up the phone and you yell at the IT people.
So now you have 50%, and we should see significant increase here in bandwidth. What should we do? So this is up to 20 meg for that flow now.
Wow.
Let's see.
9 and okay, you did it on both already, right?
Yes, I did.
Yes, and the red network's to 100%, right?
Yes, it is.
Yeah, that would give RIST an unfair advantage if that was running, because on RIST with -7, you have 2 copies of the packet coming in, and only the packets that are lost on both sides are retransmitted. So it's very efficient on that.
Yeah. If you open the RIST multi-view tile on tile 3, you can see that it says 1 on the bottom, indicating there's only 1 link active, and on the top you'll see how we have been increasing the amount of loss over time, so you can see it, the little steps going up.
If I can give my remarks, we can see that RIST reach out to a level of retransmission at like 5-6 megabits, while SRT shows 9 to 12 megabits. Now imagine that you have a standard link and you have like 20 to 30% overhead. That means that you suffocated completely your link. So the link will go down. Basically, the SRT receiver and the decoder might choke, and you would need to do a manual or automated recovery of that unit, because the link is fully choked with retransmissions. While in the RIST case, you still have some bandwidth. Might be, not fully, but might be. Usually we don't recommend going about 30, but if it's an occasional jump, then it's still okay to use. This is where RIST will shine, and tests made several years back showed that RIST was able to recover almost 89 up to 90% packet loss, which was crazy, but those were intermittent events.
Right. Another
Yes.
important factor of the difference between the implementation of the protocols is that whenever this cascade failure occurs that we're describing, where you have a limited bandwidth and suddenly a network event occurs and retransmissions just get out of hand and saturate the full bandwidth, right? I call that a cascade failure. When that happens with SRT, there's no coming back or bringing the network back unless you physically disconnect the device from the network or power cycle it, right? Almost all the implementations of RISC, or at least all the ones I know, have built-in mitigation code that let the devices come back from cascade failure. That was part of our best practices and all the effort we put into designing the protocol. Make sure people knew that that's a clear use case that needs to be handled.
And to supplement on that, if you have the ability to reduce services or PIDs, now RISC support that capability. So if a receiver feels that the link might be saturated, it can signal the sender, reduce the source, emit services or PIDs until that choking point is basically gone, and you can come back and resend those streams.
Yes, another thing that can be done in RIST is, and again, we're focusing on that kind of stuff, not because it's proprietary, but it's because it's open, is the source adaptation. So if the RIST device supports it, the encoder can modulate the bitrate, can bring it down and adapt, because at the end of the day, if you have 4 megabit pipe, you're not going to be able to fit a 5 megabit stream on that 4 megabit pipe. So RIST has standardized, common, open mechanisms to do that, to control the bit rate. So is there any other requests on the
Do we want to make this 50 on the other path as well?
No,
And
I
then
think
you
we
can
need to
show we're
drop.
instructing them. Go ahead.
I believe we can drop the 50. It's not usable. Maybe people have let's
Okay.
take a request from the audience.
Okay. The other path is still 100%. That's all I'm saying.
Yes. Can you let's do something, drop to 30
Okay.
and put the other part at 30. Let's see what happens. Because now
Okay,
we
so
have,
this is 30.
and make the red network instead of 100% loss, 30% loss.
Yeah. That's what I just did. And now I'm going to change the
Red
other
network
path
is, red network is
to
7.
30. Yeah, I did that. 30.
Can we simulate a limited bandwidth link? Unfortunately, we don't have we were having some issues with that function.
Okay. And then we want to go 15 to be 30 as well.
Yeah. So there's a question for the audience on a limited bandwidth link simulation. Yeah, unfortunately, we are not in a position to do that. So this is why we don't see the streams breaking up. But
Okay.
we
So everything is at 30.
yes, thank you, Jack. That we should see less retransmission on the RIST because it's got the other link as well. So there was a question about simulating a limited bandwidth link, and unfortunately, we're not in a position to do that. We didn't prepare for that. Sorry about that. Any other questions or any other requests?
Just to remark, with the change that Jack did, we can see on the RIST that we dropped to a very low amount of packet loss, which is almost like I would call it noise, while the SRT is still challenged with the previous configuration. Maybe we need to alleviate it a little bit.
Yeah, we now have -7, right? So we only requesting packets on the RIST that don't make it on both links. They're not.
And so this has dropped down to 10 here, and it's still up here above 20, almost 30 points.
Yeah,
on the SRT.
Yep.
The SRT is having trouble to regain consciousness because the buffer may be big, it will take it some time, but right now it's still at a very high level. You reduce it to 10% packet loss?
I can.
Or what's the level with the SRT right now?
I think it's 30, right, Jack?
Everything is 30.
Okay.
And you want to go to
No. It looks similar to 30. I thought that you reduce it to 10.
Yeah,
so yeah,
everything is 30.
It looks like 30. It's almost 5 megabits. The stream is like 6. The real queue retransmission is 5. It's very high.
Okay. All right, last chance. Any other requests?
Any technical questions to this panel?
Yeah, what you have here is the guys who designed RIST and the RIST AG chairman who herded the cats and got consensus.
And the innovation. Don't forget the innovation.
Innovation. That's one thing that's interesting about RIST. The protocol the TRs only specify the minimum for interoperability. There's a lot of latitude for you to be smart about it. So can do a good job. Yes, we have multiple vendors between the sender and the receiver. The senders are Cobalt SIP radios and everts, and the receivers are all SIP radios. We have done in the past, in the early days of RIST, we've had done full interop matrices where we had 9 vendors and everybody was sending from a different vendor and receiving from a different vendor. If you go into the RIST Forum YouTube channel, you can see many of those interrupts. We did them in the early days during IBC and NAB. And in many cases, those were all independent implementations. Everybody implemented from the spec.
And different protocols, profiles, like simple profile, main profile,
Yes.
with encryption, without encryption.
Yeah, we had a very nice dirty hands interrupt first, fueled by pizza.
And far.
Yeah, I found in that at that time that G knows how to make FAR, which impressed me. He didn't make it for us, but he knows. Okay, he knows how to make protocols and FAR. All right, if there's nothing else, thank you very much for attending. We expect to have more of these, or at least a paper coming out in the next few months. You keep an eye for that. And again, if you have any questions, you know how to find us, or info@risc.tv will get to the people it needs to get. Thank you.
Yes, and if you have any suggestions for future material, please let us know. And this content will be posted on the YouTube channel in the next few days. So feel free to share and disseminate. And thank you so much for coming. Have a great day.
Thank you.
Thank you, everyone.